Hello, everyone. I see we're already live, so I will just go right ahead and introduce myself. I'm Marcel Müller. I'm a platform engineer at Giant Swarm, and today I'm here to talk to you about operators, Kubernetes operators to be exact. So let me also share my screen. See the slides very well. Kubernetes operators. I wanted to give like kind of a talk that is more on the introductory side. So what are they and why would you need them? You will see throughout the talk that we also get into deeper topics, but my main interest here was to give you a baseline of what really are operators, because I think a lot of people have seen operators all over the place, but maybe don't quite understand what they are. And then why would you need them? Why would you use them? And when does it make sense for you? And from here, started with the basics. So this is always a little bit like, no one wants to deal with the basics. But I think it's very important in this topic to get into the basics, even though it might not be super interesting. But please bear with me while we get through some of the basics to help you understand later on the more complex topics. So the first basic thing I wanted to talk about is just Kubernetes objects. I think everyone kind of knows in their mind what a Kubernetes object is, but sometimes like defining it and really reading up on the docs makes a lot of sense. So the slides will also be uploaded. I think I uploaded them already. So you can later on click on the links and get into reading. But basically a Kubernetes object is a persistent entity in the Kubernetes system. You've seen them all over the place when you do kubectl get pods. Get pod. What you're retrieving is basically objects in the form of YAMLs. And these objects are stored in etcd, and you know the drill. What's kind of interesting about objects in Kubernetes is each object has some fields that are always there. So for example, each object has a spec, a status, and metadata. And metadata is kind of self-explanatory, right? So metadata of an object in Kubernetes always looks the same pretty much. It's always like the name, the namespace, labels, annotations. So it's always the same. It also has like the resource version and so on, but let's not get into that. That is maybe a more in-depth topic. And then there's two top-level fields, which are the spec and the status. And these have a specific meaning for Kubernetes objects. So spec is the desired state of the object. So when I create a pod, and I put in the spec, I want this pod to have a certain image, then it is my desire, or the desired state of this pod is to have this certain image. And the status is basically the reflection of the current state, which would basically say, does this pod have the image? And from there, we can also look at like an example of a deployment. So deployment has a spec, which dictates which fields are allowed, and also has like a resource definition that is built into Kubernetes, which basically says these fields in the spec are allowed. Like you can fill in these fields in the spec. And then Kubernetes itself, or the controller manager, takes care of the things you put in the spec and, for example, creates pod objects for you. If you have set like replicas to 3, Kubernetes will take care of creating 3 pods. And that will be then reflected in the status of the deployment, because you will see, okay, there's a replica set, and then there's pods, and so on. But this is the basic concept. So spec always the desired state, status always the current state. For built-in objects, Kubernetes itself, or more specifically, the controller manager, takes care of taking action to bring the current state closer to the desired state by, for example, creating pods in a deployment. Sounds pretty straightforward, right? I think most of you have kind of understood this to a point. And from here, we can kind of now talk about how can you extend this model. And extending this kind of then goes immediately into custom resource definition. So custom resource definition is by design an extension of the Kubernetes API. So how we can interact with a pod, we want to extend that to have like a new entity, for example, and we want to interact with it the same way as I could interact with a pod through kubectl and all the other things. And for this, custom resource definitions are then registered to the Kubernetes API at runtime. So whenever you add a new custom resource definition, it needs to be registered. And they're usually supplied from the outside. So usually Kubernetes itself doesn't bring any custom resource definitions, but it's different toolings, or when you install something, that you bring these custom resource definitions with you. And they are basically a reflection of structured data, which is then stored and handled by Kubernetes. And this structured data also allows some validation or defaulting. So for example, when you create a CRD or when there is a new custom resource definition, which extends the Kubernetes API, you can say this string is not allowed to be empty, or this number must be greater than 2. So basic validation and defaulting is also in there. Now, this all seems kind of vague. So let's look at the next part, which is the custom resource. And the custom resource is basically a custom, an instance of a custom resource definition. What does that mean? So the custom resource definition is basically defining a type, and a custom resource is defining an instance of that type. So if you have registered custom resource definition, you can then create custom resources, which are the instances of your custom resource definition. Sounds pretty straightforward. Interesting to note here is these are just Kubernetes objects like any other. So each one of them will have a status and metadata, and they will all have the same meaning. So whenever you look at some custom resource, you can always rely on there's going to be metadata, which is the name and the namespace. There's going to be a spec, which kind of dictates what it wants to be. And there's going to be the status, which kind of dictates what state is it currently in. And with this extension of the Kubernetes API, we can handle these as any other objects in the Kubernetes API. So you can delete them, you can create them, you can watch them, you can do basically all the standard stuff. And it's validated and defaulted against the custom resource definition we talked about earlier. So when you create an instance of when you create a custom resource, it's validated against the definition and the custom resource definition. Okay, so far so good, right? So just really quickly, you should be like, yeah, I got this. We have Kubernetes objects, I know them, they're everywhere. We have custom resource definitions, which kind of define new types and extend Kubernetes. And we have custom resources, which are instances of our new type. You know this from other programming languages, just transfer that knowledge here to Kubernetes. And these custom resources are really treated like any other object. So you can interact with them however you please. So from this, we now get to, well, how do operators work? Like, what is an operator? How does it interact with the custom resource? None of this is explained so far, right? We just have these new types. There's just some data, but we're not doing anything with it. So from kind of first talk about a more general pattern in Kubernetes, and that's the controller pattern. And this pattern, for example, you have also applied to what we talked about before, the standard Kubernetes objects. So a controller watches at least one Kubernetes resource type, and the controller for that resource is responsible for making the current state come closer to the desired state. Let's wrap our minds back a few minutes. When I talked about a deployment and how when you set replicas 3 in a deployment, there's going to be a replica set with 3 replicas, that is handled by the deployment controller. That deployment controller lives in your controller manager on your Kubernetes control plane, previously called master. So it lives right there in that component. And it's basically just a controller that does exactly that. It sees a deployment, or it has a watch on all the deployments. It sees that the spec says, hey, I want 3 replicas. And then it tries to make the current state adjust to that by basically creating a replica set with 3 replicas. So it's always trying to align the spec with reality, and it always reports the observed current state in the status. That's the controller pattern. And now you already understand what the controller manager basically does. So when your controller manager is broken and stuff like this doesn't happen, check the controller manager. It's just a little debugging tip on the side here. So, but this is now controllers, but the talk is about operators. So how does it relate? So let's talk about the operator definition now. And it's very close to this. So when previously we talked about, okay, we have a controller, an operator is basically the Kubernetes controller concept, but living outside of your control plane. So an operator is basically a client of the Kubernetes API that doesn't live in the controller manager or directly on the control plane. So basically, it can be any pod that has the same logic or similar logic to a controller or implements the same controller pattern, but is implemented by someone else and lives outside of your control plane. Sounds pretty straightforward, right? So we have controllers live in the controller manager usually and handle the base Kubernetes objects or the standard Kubernetes objects. Operators live outside the controller manager in some pod somewhere and handle usually custom resource definitions, but they can really handle anything by definition. Okay, that was pretty cool. We can also see this here again. So on a master, which is now called control plane, we have a controller manager, a Kubernetes API, and a scheduler. And the operator pod, which does like the work of a controller, but outside the master, basically watches a custom resource in the Kubernetes API and is therefore a client of the Kubernetes API, just like any microservice could be. So far, so good. Let's talk about what does an operator do, and let's explain this a little bit more in depth again. So this is a very simplified look at the control loop of an operator. And while we talked previously about the basics, it's now very important to really understand this control loop for you to use operators, to debug them, or to develop them. Because every operator works at a base level in this exact way. There's not much variance there in this very basic control flow, and it makes it really easy for you to get into a new operator or to debug one if you truly understand this. So let's look at this example, and we start at the top left. There we have the custom resource, which has a spec and a status. And as we defined previously, so the spec is the desired state and the status is the current state. And then inside the operator, we see this green box, which is observe. So what the operator does in the first place is it observes what is the desired state in our spec. So what does the user or the one that created the custom resource wanted to do? And then it checks what is the actual state, like what is actually there. So it's just like observing what is there, what does the user want? And the next step in this blue box, we then see, okay, now we need to analyze what needs to be done. Like, is the desired state and the actual state equal? Then we don't need to do anything. Are they not equal? Then we go into the act step where we now need to act. So acting basically just means we need to change the actual state to reflect what the user wants in the desired state. And additionally, usually in the same step, the operator writes to the status what the current state is. Now, it's very important to note that the current state is the operator's viewpoint. So the operator or whoever implemented the operator will write to the spec what at that moment the operator believes to be the current state. Doesn't mean that this always has to be 100% accurate because it's just code, right? But it basically writes down information about what the current state is. First of all, for the user to see what the operator believes to be the current state. And as you see, this is like a circle, right? We always go from observe, analyze, act, back to observe. This is because an operator will go through the cycle regularly. So every 30 seconds or so, it will look at every custom resource and it will go through the cycle for every single custom resource. And it will compare again through the cycle to check, did anything change or does it need to change anything additionally? Very, very important as well. And additionally, if the custom resource is changed, so if a user edits the custom resource, we also get, like, through this green path, an event which basically triggers the new observe step for the operator. I hope this kind of makes sense for now, but we will also look at a more applied example to kind of give some more reference. I've chosen here Prometheus Operator because I believe it's one of the operators that is most used by about everyone. So everyone that runs Prometheus at one point or another is also going to run Prometheus Operator. And here we can kind of go through the same motions. So we have a custom resource. The custom resource for Prometheus Operator is, I think, just called Prometheus, where we have a spec, which is basically what is our desired Prometheus? Like, how do we want our Prometheus to look like. That's what the user fills in. The status, again, is what the operator believes is the current Prometheus. And then we can go through the same motions and we see, okay, the operator will observe what does the user want the Prometheus to be. It will check what is the current actual Prometheus pods, basically, or what is actually there of that Prometheus. Then it will analyze if it needs to do any changes, and then it will act by altering basically the actual Prometheus deployment. And then write this information to the status as to what it believes is the current Prometheus that's running. And you can also see here that when we change something in the spec, the operator will go through its loop again and it will update this in the actual Prometheus. If you've understood this, then you've understood the core design behind operators. And it's really that straightforward from a conceptual level, but it's really important to understand this in order to effectively debug them and effectively work with them. Now, really quickly, I already touched on this slide a little bit. How does an operator-user interaction take place, right? So how do we as a user actually interact with the operator? And this is kind of where a lot of people have problems because they want to talk to the operator directly, but this is never the case. So users always only change the custom resources which are applied to the Kubernetes API. The operator is also a client of the Kubernetes API on the other side, basically. But you never directly interact with the operator. It always goes through the Kubernetes API. So meaning that you can do any normal action you would normally do with other Kubernetes object also on custom resources. And inversely, it also means the operator cannot be running, right? The operator could be dead or not doing anything, but you can still interact with it, with the custom resource. It's just that nothing will happen because the operator is not running. And the Kubernetes API will give you like a thumbs up because for all the Kubernetes API is concerned, you have done a valid action. It's just that the operator on the other side didn't do its actions. So this is also important to understand that you basically have the Kubernetes API in the middle that handles all your objects. And on both sides, you have users applying stuff. That can be user through kubectl, or it can be some automation. And on the other side, operators watching and listening and then taking some action. Now, we have talked a lot about like, okay, how do they work? What do they do? But what problem are operators actually like trying to solve, right? So far we have explained this is an operator, but not explained like why should you use an operator? Like what is the problem that the operators are like designed to kind of solve? And here we can kind of talk about first a little background information that then will make a lot more sense in the next slide. So there's a certain ops lifecycle in the cloud. I think we're at a DevOps conference, so I believe most of you have heard of this, but basically we have like these words of day 0, day 1, and day 2 ops, where day 0 means it's just like planning and design. So we're not doing anything that is like taking actual effect. We're just kind of planning out what is our component going to be and what's the design going to be and so on. Then we have day 1 ops, which is installation and setup and getting everything running. Tools in this category could be like Helm, for example, gets you to an installation point or setup point, or just kubectl apply or something like this, or like some GitOps solutions. And then we have day 2 ops, which are not anymore confined to I only want to do a deployment, but also I have a running system, and the running system needs to have some kind of maintenance, optimization, and over the lifetime it needs to change to the environment and it needs to keep evolving. These day 2 ops are usually defined for like generally live running systems, where something cannot just like, you can't just delete it and reinstall it and everything's going to be happy, because then you have a downtime. But more in the sense of, hey, we have a continuous effort here and we need to continuously change our application to be happy in the cloud for this lifecycle. And this day 2 routine, for example, for stateful sets can look like this. So we have, again, some kind of observe, analyze, and act steps, where we have ongoing life cycles. For example, in a stateful set, we can have a Kafka or Cassandra. We need to scale up and scale down. And to scale up and scale down, we need to know what is the current state. We need to observe, do we need to scale up? Then we need to, first we need to observe how many replicas are there, what is the actual demand. Then we need to analyze, do we actually need to scale up or do we need to scale down? And then we need to act by actually scaling up or scaling down. And here's the very important part. Often this requires domain-specific knowledge. What is domain-specific knowledge? Domain-specific knowledge means I cannot scale a Kafka in a similar way that I scale a microservice. That is just generally true. If I do the same things, it will explode. So I need some domain-specific knowledge, particularly, for example, about Kafka, to know how am I going to scale it. Or, for example, for Cassandra, to know how am I going to scale it, or how am I going to recover from certain failures. All of this can be very specific to the domain you're operating in. So, for example, if your database, like a few replicas go down, the recovery can look very different from database to database. And this is kind of domain-specific knowledge that you need to have to follow this day 2 routine and to keep your systems running. And the main goal we have here is we want to automate this. And as you saw on the left side already, your mind should be exploding, right? Operators are basically designed to do these day 2 operations. They are designed to have this domain-specific knowledge coded in and then observe, analyze, and act exactly how you would expect them to for this domain-specific use case. So, for example, if you have Cassandra operator, the operator will contain logic which is specific to how to recover Cassandra or how to scale Cassandra and so on and so forth. So this is specifically what operators are designed to do. And now we can just basically come to the resolution that, okay, operators are designed as a Kubernetes native solution for these day 2 operations problems that we generally have when operating Kubernetes or when operating certain applications on Kubernetes. Again, we can look at some examples. We already talked about them, but just to reiterate, we have, for example, Prometheus Operator, which is a Prometheus custom resource. It creates the pods in the stateful set according to whatever you set in this spec, and it continuously reconciles the desired configuration with the actual deployment. So it will do some of these day 2 actions to make sure that your Prometheus is not super dead, which can happen if you, for example, which is like kubectl apply a Prometheus and then the configuration doesn't make any sense. You know what I mean. It's more continuous in this sense. Same for like database operators. There's a million of them. We also can take a quick look. But for example, Couchbase operators, same thing. Stateful set, it continuously reconciles your desired configuration with your actual deployment and takes certain actions if it recognizes that those need to be taken. Generally, there are lots of operators, and most of them can be classified into 2 parts. So there's one operator, one set of operators that generally package applications in easier to manage interfaces and take care of these day 2 operations. So that is basically just application management where everything is in Kubernetes. So the operator is running in Kubernetes, the application is running in Kubernetes. It's just managing inside Kubernetes. Examples would be like we talked about Prometheus Operator, Cassandra Operator, all the database operators are examples of that. And then the second example would be for managing infrastructure. So if you manage infrastructure, like for example, Cluster API. What does Cluster API do? Cluster API creates clusters from Kubernetes. So you can have like a custom resource, which is just called cluster, and then it creates a new Kubernetes cluster for you. The difference here is that the infrastructure which is managed is outside of Kubernetes. So it's not managing in Kubernetes itself, but it's managing outside of Kubernetes. Cool. Now, the question you probably ask yourself is, should I use operators? And my advice, so from using operators now for 4 years, I think I've been involved in using operators, writing operators, developing operators. Generally, it's a good idea if the maintainer of the project have created an operator. Example would be there's a database and the database maintainers, like that maintain the project, have created an operator for the database. Usually they have knowledge or domain-specific knowledge on how to work with the database that is then encoded in the operator, and that is usually very helpful. But, now this is the but, there are many open source implementations for operators by people that are, for example, not the maintainers. And then you need to be careful because they will still be opinionated. So they will still do certain things where the person that implemented them assumes this is the right way to do things. And this can have problems where you can have quality problems in your operators, or where it just will not work properly. And then you have basically an operator which is kind of a black box for you, but yeah, it doesn't really match your requirements, and finding that out can be a little bit difficult. So generally look at the operators you want to use. But if the operator was brought up by, for example, the maintainer of the project, it's generally, in my opinion, a very good idea. Now, you have a project and you're asking yourself, okay, cool, we talked about operators now, how they work conceptually. We talked about what they do and how they look like and if we should use them. But should I also build one? Like, I have a project, should I just build an operator for it? And my answer is not necessarily. So why is my answer not necessarily? The first question you should ask yourself, do you really need an operator? What I have seen in the past year so far is kind of, or multiple years, is that a lot of the time people will, for example, implement an operator because it's a cool thing to do, which I get, and that makes total sense if you have the time and you want to do it. It's just that often there are other solutions that are simpler and fit your requirements better. And I don't want to be the kind of person that introduces operators to you and says, every problem you have the best solution in operator, because this is simply not the case. You should also evaluate other tools which might be better to fit your job. For example, if whatever change you need to do only needs to take place when you apply an object or to validate, then you should look at webhooks. They have come a long way. OPA is like one solution. I'm personally more a fan of Kubernetes, which is a more Kubernetes-centric solutions for implementing webhooks easily and in a really Kubernetes native way. So that might be a solution, or just deployment tooling. With GitOps tooling becoming more mature, especially Argo CD and Flux, I think it makes a lot more sense to not worry about writing an operator yourself too much, but see if you can make it work with some GitOps tooling, because you get great benefits from that as well. And then finally, even though a lot of the examples I mentioned, mainly through the database operators that exist in variants, deal with autoscaling or scaling these databases, you should also look for your application if you really need an operator to do scaling, or if you can, for example, use some autoscalers that already exist. A great example would be Keda, I don't know how it's pronounced, Keda, which is basically Kubernetes autoscaling based on events, which makes it a lot easier to implement autoscaling. It's a really cool project in that area. So generally consider your options, and if you're still really sure you want an operator, then you're worth the effort. Day two operations can be really painful, and operators can help a lot there. But you should still consider that implementing an operator is kind of the same effort as implementing a microservice in the end, because this is what you're doing. You're implementing a microservice inside Kubernetes. And that means the code needs to be maintained and tested like any other software. bugs in your day 2 operations can be just as detrimental as bugs in your actual software you're running. So be aware that you're not going to write a simple operator, slap, I'm done on it, and never touch it again. It's going to be a software development project, which you should be aware of, that you are taking on this additional work, and you should not underestimate this effort. Treat it like you would treat a new component that's being introduced. Then finally, all these check marks you have passed, so you really need an operator, you know the effort and you want to go there. Then how do you build one? And thankfully, this morning, the first talk was already build your own or build your Kubernetes operator with the right tool by, I can't pronounce the name, Rafael. I hope I didn't mispronounce your name. But he did a great talk earlier this morning. So I would just defer you to there. If you really want to get into implementing the operator, this is the way to go. And we will now focus a little bit on debugging the operator, because you can debug an operator without knowing how to implement it. To a very large degree, you can debug what is happening, and you can debug problems in your operator without actually knowing who implemented it or how it's implemented. And what I kind of want to prevent you from doing is like this beautiful GIF I put here. You should not be going insane trying to deal with your operators, because it can be really frustrating if you don't understand what's going on, and therefore have problems debugging. Thankfully, we have now covered the basic conceptual knowledge, but let's go into some debugging tips. And again, the PDF will be available. I've put together a small little checklist for debugging that are just going to be some pointers to help you out if you don't know much about operators, but you need to debug some. First of all, the most basic thing is find the custom resource which is not behaving. So for example, you have a Prometheus that's broken. Try to find if there's a Prometheus custom resource that matches your Prometheus, because this is going to be the first step. Finding this can sometimes be not super trivial depending on the operator implementation. Usually there's some kind of annotation that helps you out, but you need to find this custom resource, or you need to make sure it doesn't exist. And you need to check the status and events on this custom resource for error messages. So you can just, for example, going back to Prometheus operator, if you do kubectl describe Prometheus and then the name of the custom resource, it will give you the spec, the status, and at the bottom you will see with some dotted lines the events. And all of these are written by the operator. So all of these will show you some information that's provided by the operator. So that can be really helpful. And then obviously do some basic checking on the spec. Sometimes the spec can look kind of wild, and therefore always feel free to check that and make sure that's correct. And now you have found the custom resource. It still looks wrong. You have no idea what's going on. Find the operator, which should take action on your custom resource. A few pointers here. The operator does not need to be running in the same namespace as the custom resource. So always check all namespaces to find the operator, because an operator can watch everywhere, and therefore it can be a completely different namespace. Check the RBAC permissions if you have trouble finding the operator. Why the RBAC permissions? So to take actions on a custom resource, or to really work on a custom resource, an operator will have get and list permissions of this custom resource in RBAC. So this is very important to know. First of all, for implementing an operator, that you have these RBAC permissions in mind, but also you can then just sort through the RBAC permissions and check for anything that has get, list, and write permissions for the status of the object. And with that, you will 100% find out if some service account has or is working on this custom resource, and it will help you then in turn with the service account find the pod that is running the operator. Kind of a tip that is kind of backwards, but interesting to know that you can check the RBAC permissions. Finally, check the operator logs for more information. So you have found the operator, check the logs. remember the workflow of the operator. So usually in the logs, you will see some info logs where it's just pasting like what it's seeing. And then it's going to paste some logs of like what actions it's taking place, depending on how much logs it's reprinting, obviously. And this will kind of give you an overview, because you know that it's first going to observe some stuff, then it's going to analyze, and then it's going to take some actions, that you know kind of what series of logs you are looking at. And then finally, do not be afraid of restarting the operator. As we talked about previously, the operator is kind of its own independent entity inside its own little pod. As you remember, the users on one side, Kubernetes API in the middle, operator on the other side. And operators are always designed to pick up where they left off and continue their cycles. Basically, they always go through this control loop, as we talked about. You can, in theory, or you should be able to just kill them at any point. And this can help a lot of the time, because maybe just like something was wrong with your pod or whatever. You don't need to be afraid to just delete the operator pod and the deployment will bring it back, or however it will be brought back. Just some points here to really simple debugging high level. And then I also things to know, like if you are really stuck and you need to look up some stuff or generally learn, finalizers. In my experience, a lot of even experienced like operators or people that interact with Kubernetes do not know about finalizers. If you are interested, look up the finalizer concept. They can basically prevent deletion of any object. So you can put a finalizer on an object and it won't get deleted until you remove the finalizer again. Why is this relevant for operators? Every operator does this, or nearly every operator will do this. It will put a finalizer on the custom resource, and then when the custom resource is deleted, the operator will take care of the deletion of the actual state and then remove the finalizer to ensure that the CR is deleted. Just some context, if you didn't know what finalizers are, feel free to look it up. It can be really helpful while debugging operators. Then never delete the custom resource definition if there are still custom resources around. Sounds kind of like duh, but in the moment you might not think about it. Because if you delete the custom resource definition, all the custom resources, which are instances of the custom resource definition, will be gone. This means that any actual state will just hang around. Let's go to the example of Kubernetes Prometheus Operator. You have a whole bunch of Prometheus custom resources. You delete the Prometheus custom resource definition, all the pods will still be hanging around while all the custom resources are gone. No operator is going to be doing any cleanup, because all the pods are just going to be floating around without anyone taking care of them. And then you need to manually take care of deleting them. So always be aware that don't delete the custom resource definition if there are still custom resources. Or make sure you know what you're doing. And then do not run the same operator more than once. Kind of simple, because you run into race conditions. Fourth, except there's like high availability supported by the operator, then it's fine, but usually don't do it. Check Kubernetes API metrics for event flooding. If you run a lot of operators, you might start to DDoS the Kubernetes API. Usually this doesn't happen, because usually Kubernetes operators are implemented in a way that they try to follow rate limits, but just be aware that this is a possibility if you see a lot of problems suddenly. And then it often helps to delete the actual target, so the actual state, and let the operator recreate it. So for example, you have Prometheus Operator again. It has a Prometheus custom resource, and there are some pods hanging around that match this custom resource, like an actual Prometheus deployment. Just delete the Prometheus deployment if it seems stuck and you can afford to delete it. The operator will recreate it, and often there can be slight bugs where the operator can't like recover the state correctly because someone did some manual changes or whatever. Just like a few tips that hopefully help you while debugging at one point or another. So conclusions for users. Utilize operators for application management, especially if your day two ops are really intensive or you're struggling with that. Check out operators or which operators are available and so on. Open source operators are plentiful. Always check if there's one from the project maintainers themselves. I'm not saying all other open source operators are bad, but you know what I mean. It can be better to sometimes just go with the person that implemented the actual application. And then understand the basics before using operators extensively. If you've kind of followed this presentation, I would assume that you understand the basics and that you are capable of debugging operators in a kind of a reasonable way in your production environments. For developers, the plus points of operators should be obvious. Like they use operators to offer like a native management experience of your application for day 2 ops. Operators can significantly improve the stability of your application that you're managing, or even if you're managing something from outside. But do not underestimate the effort of implementing one. Even though it's easy to get started, it's still kind of a microservice you're running. Be aware that this is the case. So don't start just like writing 15 operators and think this is all going to go fine. It's kind of the same as a microservice. It still needs some love and it needs some testing, and you need to take care of it. And then finally, I would like to say thank you for everyone that listened. If you have any questions, now's the time to ask them. Feel free to stay in touch, like either on Twitter, I'm like at Marcel, or GitHub, or follow up on Slack. Really anywhere. I'm on the Kubernetes Slack as well, where I'm kind of part of Kubernetes projects and so on. So if there are any questions, now's the time. If there's anything to say, now's the time as well. Let me check if I can find a chat. I'm not sure if I can. Cool. I don't see any more questions coming up. So I would end the session here. Thank you everyone for listening. I hope it was helpful to you, and I hope you had a great time. Goodbye.